Large curved displays offer an ideal platform for viewing 360-degree content. However, such displays often restrict users to a 180-degree viewport, which is the visible area on the screen. Traditional input methods for navigating 360-degree workspaces, such as handheld controllers, can reduce immersion, since users naturally direct their heads toward a region on screen before interacting with it. Our goal was to explore a set of mapping functions where head movements can be mapped to the workspace movement. Through a user study, we explore 3 rate control functions: linear, sigmoid, and polynomial, and 4 zone control functions: continuous, friction, additive, and interrupted, for head-based viewport manipulation. The linear function creates a consistent mapping where the velocity increases uniformly with the degree of horizontal head rotation. For the sigmoid function, most workspace velocity values are mapped around the middle range near 0.5 for head rotations that are neither extreme nor minimal. The polynomial function results in very slow workspace movement for small head rotations and a rapid increase in speed for larger head rotations. For the zone control mapping functions, the 180 workspace was divided into stop, constant, dynamic, and flick zones. To explore the impact of different zone control mapping functions, we defined a dynamic zone where each function exhibits its unique behavior. In the stop zone, the workspace velocity is 0, and we introduced the constant zone with constant slow velocity. To start a flick, the user needs to move their head from the dynamic zone to the flick zone. In the continuous mapping, when the user performs a flick, the workspace velocity is updated based on the flick. The friction mapping is similar to continuous mapping. However, it includes an additional coefficient that determines how long the workspace takes to reduce speed to the point of stopping. The additive mapping function is similar to the continuous mapping function, with the key difference being that participants can increase the workspace movement through additional flicks. The interrupted mapping function is also similar to the continuous mapping function, with the key difference being that whenever the cursor enters the dynamic region, the workspace movement velocity is reduced to 0. We define the display window as the visible window within the workspace, and we choose 3 different display windows: 400 centimeters, 600 centimeters, and 800 centimeters. Additionally, we selected 3 target distances: 500 centimeters, 750 centimeters, and 1000 centimeters. Our findings indicate that the rate control functions are significantly faster and more preferred by the participants than the zone control functions. The polynomial rate control function achieved the fastest trial times and received the highest objective feedback ratings and was the most preferred by users. We conducted a second study to see how our best head-based technique compared against baseline techniques. With head polynomial, users navigated using their head movements, just as in our first study. With drag and flick, users held a controller button and moved their hand to drag the map. With push and release, users simply push the controller's joystick left or right to move the map continuously. The task required users to gather information from specific markers as prompted. To complete each trial, users navigated to and selected information from 4 markers in the given order. Once information from all 4 markers are selected, a new trial starts where the system again prompts the user to select information from a particular country. The head polynomial technique was significantly faster than both the joystick and the drag and flick methods. All techniques were equally precise with no significant difference in additional attempts. Furthermore, participants rated the head-based technique as requiring the least effort, and it was overwhelmingly their most preferred method, with 12 out of 18 participants ranking it as the best. Our second study confirms that head-based navigation is faster, highly preferred, and more efficient way to navigate large workspaces compared to standard controller methods.